through and how we are able to accomplish it.
Welcome everyone. We are trying to design an automatic powerline load shedding system. As you can see, we are giving different loads to the system, and this is our power line. These are the different loads. Like for example, that's we are using that as our domestic supply. This is like our factory, and we are taking this to our hospital. So we are designing system in such a way that once there's too much load on domestic supply, it will turn it off in order to balance the loads on these other different sectors. Like for example, the factory is a crucial entity, so we can't just shut it down. But for the part of balancing the loads, we make sure that the power supply or the main grid can accommodate these loads that are connected. This will be our control room. We shall have our LCD, our main switch. This is our isolator, mainly driven by a servo motor. The main isolator. Then this is like a hospital. So we shut off domestic with the factory, and in case the load becomes too much, we shut off the factory and then we leave hospital. These are some of the loads. Right now, for example, this is our monitor. They are patient monitors in hospitals. They're just using it for display and as a load. So this is what happens under normal operation. So we turn on our main switch. Everything comes on, as you can see. So the relays have been turned on. So this is our domestic, industrial, and then this is our hospital. So these are our patient monitors. These are the different motors. So to start the process, press the start button. This is the system generally under normal operation. While our hospital is on, our factory is on. You can see some of one of the motors is running, and then our domestic is on. That's for the start under normal operation. Under domestic, when they overload, let me say they put, it's still under normal operation, because domestic in most cases they don't use heavy loads, so we take it to be a normal operation. So when you go to the factory side, we've overloaded the system, and now domestic is on and the factory is running. At the same time, the hospital is running. So when we overload now the hospital side, let me say we have more critical loads this side, we use these switches for switching on different loads. So now also the factory is off, as well as our domestic is off. That's how basically the system works. So under other operations, maybe we start isolating the loads. Factory comes back. Comes on. Then when we remove some other loads, like all this goes on, and there's also a current started here, but also the domestic side has to be on. So when we remove some of the loads again from factory, the system stabilizes. And this part, that's where our HMI is supposed to be put.
For short circuit detection, we show the two phases.
That's generally the operation automatic power line load shedding system. Thank you for watching. Subscribe, yeah, to get more insightful innovations. Thank you.